Deep beneath the Horn of Africa, something has been beating like a heart for millions of years. You can't feel it, and you can't hear it, but in 2025, a team of scientists finally proved it was there. They found rhythmic pulses of molten rock, surging up from the mantle in waves and pressing against the underside of the continent. What nobody had fully understood until recently was what those pulses are doing up there. They're slowly tearing Africa in two and carving out the basin for an ocean that doesn't exist yet. So how does a solid continent, one that's held together for tens of millions of years, begin to come apart? To understand it, you have to look at a scar that runs down the entire eastern side of Africa. Geologists call it the East African Rift, and it stretches for thousands of miles from the deserts of Ethiopia in the north all the way down toward Mozambique in the south. On a map, it looks like a series of long valleys and deep lakes lined up in a chain. What you're actually looking at is the seam where a continent is splitting into two. For most of human history, we thought of the ground as the one thing that never moved. It turns out the crust beneath our feet is broken into enormous slabs called tectonic plates, and those plates drift. Africa sits on one of them. But along that eastern scar, the single African plate is pulling itself into two separate pieces. The larger western piece is called the Nubian plate, and it carries most of the continent. The smaller eastern piece is called the Somali plate, and it carries much of the coastline along with the island of Madagascar. Between them, the ground is stretching thinner every year. The engine behind all of this hides in one specific corner of Ethiopia, a place called the Afar region. Afar is one of the strangest pieces of land on the planet. It sits low, in places well below sea level, and it happens to be one of the only spots on Earth where three separate rifts meet at a single point. The main Ethiopian rift, the Red Sea rift, and the Gulf of Aden rift all converge there. Picture a giant three-armed crack in the crust, and Afar is the joint where all three arms come together. To stand in Afar is to stand in one of the most extreme landscapes on Earth. Parts of it lie more than 100 meters below sea level, and the air can climb to some of the hottest temperatures ever recorded in an inhabited place. In one corner, a volcano holds a lake of open lava that never fully cools, one of only a handful anywhere on the planet. Bright yellow and green mineral springs bubble up through the salt flats nearby. It looks less like Africa and more like the surface of another world. That alien landscape exists for one reason. The crust here is thinner and weaker than almost anywhere else on the continent. Underneath that joint sits a plume of superheated rock rising up from deep in the mantle. That rising heat does two things. It softens the crust from below, and it pushes upward against it. Over millions of years, as the plates on either side pull apart, the crust between them stretches out and grows thin, almost like a sheet of soft plastic being slowly drawn from both ends. And when a sheet gets stretched thin enough, eventually, it tears. Now, the pace of all this is almost impossible to picture. I mean, think about that for a second. The two African plates are separating at a speed of just a few millimeters a year. That's slower than your fingernails grow. The Arabian plate to the north moves a little faster, closer to an inch a year, but even that is glacial by human standards. At those speeds, nothing seems to be happening at all. And for a long time, that's exactly what everyone assumed. But here's the detail that everyone missed at the time. A rift doesn't always move a little at a time. Sometimes it lurches. In September of 2005, in that same Afar desert, the ground gave way. It started with an eruption at a volcano in the region, followed by a swarm of hundreds of earthquakes. And then, over a matter of days, a crack roughly 60 kilometers long tore open across the desert floor. In some places, the ground pulled apart by as much as 8 meters. Molten rock forced its way up into the gap from below, hardening into fresh new crust. To put that in plainer terms, a stretch of Africa, the length of a small country, ripped open in less time than it takes to plan a vacation. Scientists who study these things had never watched anything quite like it. They realized they weren't just looking at an earthquake or a volcano. They were looking at the exact process that builds an ocean floor, happening on dry land, right in front of them. And the desert wasn't finished. Over the next 5 years, more than a dozen more of these underground cracks forced their way up into the same stretch of rift, each one widening the wound a little further. Geologists studying the area noticed something uncanny about it. The way the ground was splitting, the size of the segments, the rhythm of the eruptions, all of it looked almost exactly like the process that happens at the bottom of the ocean, where new seafloor is born along the mid-ocean ridges. The only difference was that here, it was playing out on dry land, in plain sight. There's a reason this story is still talked about today. What happened in Afar was a preview. It showed, in fast motion, the same thing the whole rift has been doing in slow motion for millions of years. Fresh crust was forming in the gap. The two sides were drifting further apart. Given enough time, water finds a way into a scar like that. And once the sea gets in, an ocean begins. While the desert in Ethiopia was quietly making history, something very different was happening a few hundred miles to the south, in Kenya. And it led to one of the biggest misunderstandings this topic has ever produced. For a while, everything about the Kenyan story seemed to fit perfectly. In 2018, after weeks of heavy rain, an enormous crack suddenly split open across a stretch of the Kenyan countryside. It swallowed part of a major highway. It was wide, it was deep, and it appeared almost overnight. Headlines around the world announced that Africa was finally cracking in two, right on schedule. Pay attention to this next part, because it explains a lot about how these stories spread. When geologists actually examined the Kenyan crack up close, the tectonic explanation fell apart. The two edges of the crack didn't match. They couldn't be fitted back together the way a real tear in the crust would. There were bridges of soil left standing across the gap, and the land on both sides was flat and undisturbed. Satellite instruments that tracked the rift had recorded nothing unusual in the area. The real cause was far more ordinary. Heavy rain had washed away loose volcanic soil that had been quietly filling an old buried channel. When the soil gave out, the surface above it collapsed into the hollow underneath. The cause was erosion. Rain had carved that crack, the same way rain carves a gully into a hillside. So the most famous image most people have of Africa cracking apart is a picture of a hole that rain dug in the dirt. That was a long way from the tectonic event it was sold as. If a continent tearing itself apart to build a new ocean is the kind of thing you want to see more of, take a second and subscribe. I cover the forces reshaping our planet every week. But this wasn't just about one crack in one country anymore. Because while the world was arguing about a collapsed highway, the real evidence was sitting far deeper where no camera could reach. And that's where the newest science comes in. For years, geologists suspected there was a plume of hot mantle under Afar, but they knew very little about how it behaved. So a research team gathered more than 100 samples of volcanic rock from across the region and read them like pages of a diary. What they found, published in 2025, changed the picture completely. The plume isn't a steady, constant thing. It pulses. Waves of molten rock rise up from the deep mantle in rhythmic surges, and each one carries its own distinct chemical signature, like stripes on a barcode. Those chemical stripes repeat across the rift, and the spacing between them changes depending on how thick the plate above is and how fast it's pulling apart. In the faster-moving rifts, the pulses travel smoothly and regularly, the way a pulse moves through a narrow artery. That's why scientists started describing it as a heartbeat. The continent is being pried open from the sides and pushed apart from below at the same time, in a steady rhythm, over and over again. The next measurement was even more sobering. In early 2026, a separate study looked at the crust in the Turkana region, along the border of Kenya and Ethiopia. The crust there should be thick and strong. Instead, in the center of the rift, it had thinned to only about 13 kilometers. Along the edges of that same region, the crust runs more than 35 kilometers deep. When rock gets stretched that thin, it enters a stage geologists call necking, the final narrowing before something breaks. In at least one spot, the split may be further along than anyone expected. There's another reason the Turkana region matters, and it connects this story to something surprisingly personal. That same stretch of the rift is one of the richest sources of human ancestor fossils ever discovered. The skeleton of a young boy who lived more than 1.5 million years ago was pulled from the ground near there. Some scientists now think that's not a coincidence. As the rift tore the land into ridges, valleys, and lakes, it may have carved out the shifting, broken landscape that pushed our earliest ancestors to adapt, to walk upright, and eventually, to think. If that idea holds, then the same slow split that will one day drown this region under a new ocean may also be one of the reasons we're here to talk about it at all. For the people who live along the rift, none of this is a distant abstraction. The same forces pulling the continent apart make Eastern Africa one of the most geologically restless regions on the continent. Earthquakes rattle the ground. Volcanoes flare to life and go quiet again. New fissures open in the soil after the rains. Most of these events are small, and most have nothing to do with the grand continental split. But every one of them is a reminder that the ground here is anything but settled. So what does the finish line actually look like? This next part sounds like fiction, and it follows directly from the evidence. The two arms of the rift in the north, the Red Sea and the Gulf of Aden, are already filled with seawater. As the Afar region keeps sinking and stretching, the natural barrier of high ground that currently holds that water back will eventually give way. When it does, the sea will pour inland, down into the widening Rift Valley. Slowly, the flooded basin will grow, until a new body of saltwater separates the two halves of the continent. The eastern sliver of Africa, the piece riding on the Somali plate, will drift away as its own smaller landmass, carrying parts of Ethiopia, Kenya, Tanzania, and Somalia with it. And the countries that sit landlocked today, places like Uganda and Zambia that have never touched the sea, could one day find themselves with brand new coastlines. Whole new ports and fishing grounds would appear where there's only dry savanna today. Trade routes that have shaped this part of the world for thousands of years would be redrawn from scratch. No one alive now will see any of it. The change is measured against the age of the Earth, not the length of a human life. When will all of this happen? That's the one question the science can't answer cleanly. The most common estimate is somewhere between 5 and 10 million years, though some researchers think a full split could take even longer, on the order of tens of millions of years. The honest answer is that the timeline is an estimate built on how fast the plates are moving right now, and rifts don't always move at a steady pace. What no one seriously doubts anymore is the direction. Africa is coming apart, and the sea is coming in. And if you want proof that this ending is possible, you don't have to imagine it. You can look at the water that's already there. The Red Sea and the Gulf of Aden are young oceans, born from this very same process when the Arabian Plate tore away from Africa long ago. Go back far enough, and the entire Atlantic Ocean began the same way, as a crack between land masses that slowly filled with sea. Every ocean on Earth started as a rift like this one. The East African Rift is simply the newest. So the next time you picture Africa on a map, remember that the shape isn't permanent. Beneath that eastern edge, a slow and steady heartbeat is still beating, still pulling, still building a coastline that no living person will ever stand on. Thank you for watching. If you enjoyed this video, please feel free to like and subscribe. And if you'd like to continue watching more of my videos on the forces reshaping our planet, you can click the video on the screen now.